then B says, how far from the base of the cliff does a stone strike the ground? So here's the base of the cliff. We want to know what type of distance do we want to know? Is this vertical or horizontal? It's horizontal, so I go back up here, look for the one that I'll be using, and it's this. So distance equals velocity times time. Do I have a horizontal velocity? Yeah, here's my horizontal velocity right here. So I go ahead and put the 5 meters per second in for velocity. And do I have a time? I do. I just solved for it. 3.96 is your time. Remember, the time is the thing that ties both of these together. The time it takes to go forward is the same amount of time that it takes to fall. So I put in 3.96 seconds. Now I multiply those, and what do I get as my distance? Should be around 20 meters. Yeah, I just rounded. 20 meters is fine. So that's my answer to B. B, distance equals about 20 meters. And then we'll answer C and D at the same time. C says what are the horizontal and vertical components of velocity. And then D says what's the final speed. So we'll answer those two together. So right here, at each one of these cases really, I'll try to use a different color here. It's moving forward. I don't think that helps. And it's also falling at the same time, right? This is my horizontal component. This is my vertical component. My horizontal never changes. Stays 5 meters per second. Horizontally the same all the way throughout. What's happening vertically is that it's increasing its speed. It's vertical speed. So right before it hits the ground, notice my velocity vectors are getting longer and longer. Horizontal stays the same, 5 meters per second the whole time. It's this vertical component that changes. So right here is what I'm looking for. So I'm just going to go ahead and write in V of x. That stands for my horizontal, x, left to right. And then this component is y. That's my vertical component. It wants to know what are these two components. What are these two? Well, I should know what this horizontal component is. What is it? 5 meters per second. It doesn't change. It stays the same all the way throughout. So if it says 5 meters per second initially, that's what it's going to be horizontally. Horizontal component. So that's 5 meters per second. What is my vertical component? Well, how do I solve? If it was just in free fall, right? If it wasn't thrown with any horizontal speed at all, horizontal velocity, if I just had it fall, what equation could I use? Velocity, the vertical, right? Velocity is gravity times time. So, velocity along the y is gravity times time. Gravity, we'll say, is 10. We solved for the time earlier is 3.96. 3.96 seconds. We'll multiply those out and you get 39. You could go ahead and round that. 39.6 would be 40. We could go ahead and say 40 meters per second. So this component is about 40 meters per second. So this is the horizontal. This is the vertical. Right? The final speed, the actual speed, is the combination of both of these together. So I can take my vectors and use that head-to-tail method, where the head of one of these has to connect with the tail of the other one. So I can move these. I'm going to show you down here. Here's my horizontal component. We said was 5 meters per second. Here's the head of one arrow to the tail of the other arrow, which was my vertical. So vertical component we just solved to be 40 meters per second. So here's 5 meters per second. Here's 40 meters per second. The final is going to be this little part that I can solve for. What is this? Yeah, it's the hypotenuse of a right triangle. I have a right angle here, so I have a right triangle due to my component vectors, my horizontal, my vertical. I'm just solving for this part right here. This is your resultant vector, the result or combination of these two. So when I'm looking for this, I use Pythagorean theorem. So final velocity is going to equal the square root of my horizontal component squared times my vertical component squared. And this comes from a squared plus b squared equals c squared. Or in other words, c equals the square root of a squared plus b squared. Right? Here's the c, that's my final velocity. A is just one of these, one of the legs. So I used this, and then b is the other leg. So now I can go ahead and plug in for those. And it's the square root of 5 squared plus 40 squared. Should give you 40 meters per second, somewhere around there. So your final velocity is somewhere around there. So you have your horizontal component, your vertical component. That's what C was asking. And then your final velocity, like what D was asking, is this right here. I know that's a lot of information. I know that's a lot of steps. I know that's a lot of things to have to take into account. But you have to take it step by step. You can't try to do every single one of these things all at once. You have to solve for the first one, go back, look at what equations I have, what can I use, what can I not use. Am I talking about the horizontal? Am I talking about the vertical? Right? But the first step is to always solve for time, because that ties both of these. And then once you get time, you can use time in any one of these equations here, any 4 of the equations. And the time is the same here. The time would be the same here, here, or here. Because remember, the time that it takes to move forward and reach this point over here is the same amount of time that it takes to fall. Okay. All right, we're going to go on to the second part of this. How would the answers to A, B, and C, and I'm going to let you do this on your own, how would the answers to A, B, and C of question 1 change if the stone were thrown with twice the horizontal speed? So what was the original horizontal speed? 5 meters per second. So now we're saying, let's change that and say, what happens if you threw the stone horizontally at 10 meters per second? So A is asking for the time. So what happens with the time? B is asking, what is the horizontal distance? And then C is asking for the horizontal and vertical components of velocity. So you answer these questions. You tell me, is it the same? Is it tripled? Is it doubled? No change? You tell me about the time. If I'm increasing the speed, tell me what happens to the time. If I increase the speed to 10 meters per second, tell me about the horizontal distance. How far does it reach? And then tell me about the horizontal and vertical speed, or I'm sorry, velocity. Okay. I'll zoom out on this, and I'll let you look at this, look at your information, and I'm going to come around and take a look and see how you're doing on this. Okay. So I want you to work on the second part in your groups, and I'll come around and check.